Welcome to the Lab 6 presentation. I'm Ethan Stringham, and this is our presentation on the register file. Here's the table of contents. We'll talk about the introduction, what the lab's about, the specific parts of the register file, final product, and real-world uses. So an important part of all computer science is that you need memory so that you can store data for use later. Which is used in basically every aspect of modern computers. So one way you can store that memory is through the use of register files. And in this lab, we became more familiar with using D flip-flops, decoders, and muxes. A register file can be broken down into these three main components: the write decoder, the register locations, and the MUX. As you can see right here, this is what it will look like from a blueprint standpoint. Inside the write decoder, we can see that there are a bunch of ands and the nots that take the inputs and put them through. Right here is a 3x8 decoder. Here's a 1-bit register where it has a small mux and a D flip-flop. The 1-bit register, as the name implies, is only able to adjust 1 bit, but by putting multiple together, you're able to do many bits. The register write signal, when it's true, the data can be changed inside the flip-flop, and when it's not being changed, it will consistently output the same thing from the data out. Here's an example of what a 4-bit register looks like in Logisim, and this is many of them put together to make it so that you can change 4 bits of data. Here is the MUX that we'll be using for the assignment. It takes in the 8 4-bit datas as the inputs and returns the 4 outputs. For this assignment in particular, it's mainly just choosing which register file is going to, or which register inside the register file is going to be outputting. And here's the final product. As we can see, this is a very large thing. The decoder down here is going to take in the specific information for which decoder or which register to be changing. And up here we can see where the data that would be changed, if it's going to be changed. And then finally it comes over to the MUX, which will output whatever the current register that's being looked at. A real-world use for this would be static RAMs. Static RAMs are like dynamic RAMs, except they use electronics instead of, or electricity instead of things like magnets and other methods. They're considered volatile because when power is no longer supplied, they will lose their power and change. But their primary use in computers nowadays is for the CPU cache. In conclusion, register files primarily use muxes, decoders, and D flip-flops. Register files can be increased by adding more registers and increasing the size of the mux and decoder. And the real-world application of register files is in static RAMs.